Hello everyone, welcome back to ECD lab experiment number 7, that is to write Verilog code for BCD counter. So before going to write the Verilog code for BCD counter, we should understand what actually the counter and what actually the BCD counter. So if we are looking for the block diagram of this counter, it has the two inputs. Out of that, the one is clock and second is reset, whereas the output is count, that is 3 down to 0. So what actually the counter is doing? So counter is counting the clock pulses. Here the rising edge of the clock. It means if your clock is coming like this, so when there is a rising edge of the clock, your counter is increased by 1. That is known as your up counter. If it is decreased by 1, that is down counter. So when the first clock pulse, let us assume that counter is 0. Second clock pulse, the count is 1. Then next clock pulse, the count becomes 2, 3 and so on. Now, how much of counting it can be done, that totally depends on the number of bits or the number of wires available at output side. Right now it is a count 3 down to 0, that means 4-bit binary number, hence it can count from 0 to 16. So it is of your 4-bit binary counter. Here we are looking for a BCD counter. BCD understand binary coded decimal, that means it has the values or the numbers from 0 to 9. So total states are 10. Now to represent this 0 to 9 number, we need 4-bit binary number, and that's why your count is 3 down to 0. When the reset is 1, count becomes 0, and when the reset is 0, it will count the clock pulses. So what the number of states are? 0 to 9. It means the first clock pulse 0, second clock pulse 1, 2, 3, 4, 5, 6, 7, 8, 9. When it has a 9, it should be, once it reaches to 9, count value becomes 9, it switch to or it goes to initialize, that is 0. So again it will count when the first clock pulse 1, second, 2, 3, 4, 5, 6, 7, 8, 9. When it reaches to 9, again it should be reset. So this is simply a working of your counter, BCD counter. Right now we are going for that, the Verilog coding. So let's check. As already we have seen this experiment number 4, 5 and 6, we are switching to that experiment number 7. So go in the project, new source, we are making that Verilog module, and the name of this file is BCD underscore count or counter. Next, what the ports are available? So we are having a clock, that is input, second is reset, and the output is Q, or we can say the count, and it is 4-bit. So it is output, bus is 4, that is 3 down to 0. Next, finish. Default template is available here, it is generated. So model BCD counter, input clock, input RST, output count. What here? We are going to write, again it is if and else statement, so we have to write that procedure block always at the rate. When it will execute, it should be execute at the positive edge of the clock. So positive edge of the clock. What it will check? It will check the first is reset. If reset is 1, so what my counter should be? My count value should be 0. So count equals to, it is a 4-bit, so 4 tick B 0 0 0 0. Else if reset is not 1, so it will check whether my count value is reaching to 9. If it is reaching to 9, then it should be 0, or if it is less than 9, that means 4 tick B 9 representation, that is 1001. If it is less than 9, your counter should be increased by 1. So count equals to count plus 1 tick B 1. We add the increase by 1. If it is greater than 9 or it reached to 9, then that times what here? Sorry, else there is a if. Else what here? Else count should be, what my count should be? Count should be 0. That is as much of as simple. Counter should be 4 tick B 0 0 0. now if you are looking this, we are using here the always, so your output should be the registered data type, and we are having a single nested if statement, so there is no need of your begin and end. Once it is done, save it. Right now we are having a 4 file and we have to synthesize BCD counter, so right click on this, set as top model. Yes, let's check or let's compile it, synthesize. If there is any syntax error, it gives you. If it is not, it will be run correctly. No error, fine. So let's check its RTL schematic. Okay, double click here. So here you find that it is a counter, 4-bit counter. Okay, so in this way we have synthesized this BCD counter with Verilog code. In next video we are checking its simulations using test bench. Thank you.